Hello, and welcome to the Orbital Exchange podcast, where we're on a mission to connect and unlock the full potential of the new space economy for all. I'm your host, Regan Hinchcliffe, VP of Public Engagement at Avro Aerospace. Orbital Exchange bridges bold ideas with real-world applications, bringing together innovators, entrepreneurs, and seasoned experts to shape the future of this rapidly evolving industry. My journey in aerospace began in May of 2024, after a 13-year career in digital marketing tech, building and scaling a successful company that I co-founded. My passion for space, something I just couldn't stop talking about, ultimately set me on a new path. That experience became the catalyst for pursuing what I now realize is my true calling, space. Every day, I'm inspired by the people I meet, the ideas we share, and the technology we're building. This podcast is my way of continuing those conversations and sharing them with you all. I'm joined by my co-host and technical moderator, Brian Zetlin from Virtus Solis, a veteran aerospace expert whose career includes key contributions to the Canadarm and the International Space Station, and now to persistent, global, scalable energy from space. Together, we'll explore the cutting-edge technologies and opportunities shaping the space economy. So whether you're a student, an entrepreneur, or a professional, this is your space to learn, connect, and be inspired. So let's get started. Thanks so much, Ashley. Thanks so much, Hannah. Everybody, welcome to the first Orbital Exchange podcast, where we're on a mission to connect and unlock the potential of the new space economy for all. I'm Regan Hinchcliffe, the Vice President of Public Engagement at Avro. And Avro's on a mission to develop innovative, efficient, sustainable, and rapidly deployable propulsion systems and establish Canada as a global leader in aerospace. I'm thrilled to explore the future of space innovation with all of you. The space economy is projected to grow to an astounding $1.8 trillion by 2035, driven by advancements like reusable launch systems, like SpaceX's Starship, space-based renewable energy, Earth observation, and orbital manufacturing, and more. This growth is creating unprecedented career opportunities for entrepreneurs, for students, professionals across all industries, and not just for scientists and engineers. And personally, I'm living proof that the space economy is open to all. Just last May, I left my career in digital marketing technology, a company I founded and scaled for 13 years, to pursue my passion for space. And it's been one of the best things that's ever happened to me, to be completely honest. The remarkable people that I'm meeting, the technology we're building, and the ideas that we're sharing are all so inspirational. And I look forward to every day waking up in this new economy here. The new space economy welcomes those who dare to dream and take action. And I'm not alone in this journey from Regina. A big shout out to Satyam Singh, a local hackathon legend here in Regina, and his team from the Google Developer Group on Campus University of Regina Club for being named global finalist in the 2024 NASA Space Apps Challenge. So out of nearly 10,000 teams, they made it to the top 40. Out of 10,000 teams, one of two Canadian teams, and their innovative project, Asteroid Destroyer, aims to develop a navigator for future habitable worlds observatory. So that's just really exciting. It's remarkable the achievements that we can do, and it really shows how dedicated teams from small cities with big ideas can achieve global recognition and drive innovation. So at Orbital Exchange, this conversation doesn't end with the podcast. It's just the beginning. We're creating a community platform that will connect global experts with Canadian academia to inform future events, live Q&As, and podcasts. And we want to build a thriving and connected space tech ecosystem right here in Canada. We're going to be actively seeking founding members, industry experts, mentors, educators, and academic institutions to contribute and help shape the content and the community. Joining me today is my co-host and technical moderator and mentor and friend, Brian Zetlin. He's an accomplished aerospace engineer, entrepreneur, and educator whose career includes contributions to getting the Canadarm into space through controlled exports. He's been involved in the International Space Station and much more. He's also an adjunct professor at the University of Washington, and he brings unmatched expertise in space operations. Also very honored to feature our special guest, Dr. Ed Tate, Chief Technical Officer and co-founder of Virtus Solis Technologies. And Dr. Tate is a pioneer in sustainable energy and space innovation with achievements like the GM EV1, Chevy Volt, and wireless power transmission systems, transforming energy solutions on Earth and beyond. With over 40 patents and his contributions to NASA's cosmic technology roadmap, his expertise is invaluable, and we're really excited to have him on the show today. Special thanks to Hannah and Ashley from the University of Regina and Gate for hosting this platform as part of Entrepreneur Week. As a University of Regina alumni myself, it's a joy to be part of this celebration of innovation and entrepreneurship. So once again, there's going to be Q&A at the end, so make sure to stay through. And without further ado, let's dive in. Dr. Ed Tate. Ed, how are you doing? Welcome to the show. Let's hear a little bit about your story and how you got to where you are today.
Well, I'm doing great today. Thank you very much for having me on. One of the questions we had when we were talking earlier is like, what was my journey to get into aerospace? So I'm not an aerospace engineer. In fact, my journey actually kind of started with things I did in high school, working and selling software, selling hardware on the side. But then as I went into college, I had a chance to get into automotive. And I spent nearly 20 years in automotive. And I thought it was fantastic. I literally was working in a system of factories that brought dirt into one end, produced cars out the other, and doing this at millions of vehicles a year. I thought this was like the coolest thing to be part of. Had a chance to, see how you do these very complex products from beginning to end. And it was a fantastic opportunity to learn and had a lot of great people that helped me out along the way. My journey there, I got recruited out to work on engineering software. I spent about a decade doing that. We actually had an audacious goal in the startup that I got brought into, which was to decrease the cost that it takes to make cars. So if you're not familiar, when you get into a new car, that can represent anything from $500 million to about $6 billion to take it from an initial idea. It may be changing an old model, it may be generating a new one, but turning that into something you're going to produce an awful lot of year in and year out. So the company was EXA. We were looking at how to use simulation to replace some of the most expensive and time-consuming steps. And we actually did that for quite a few global automakers. In fact, if you drove a Jaguar, Jag was able to take advantage of this and release their designs before they had ever built a prototype, which was a huge step. That saves time and that saves money. John and I met when I was at General Motors about 15 years ago, and he kind of knocked on my door and he said, "Hey, I'd like to go do space-based solar." Well, John and I had worked at GM. He did a meandering path through SpaceX and Divergent, which is an additive manufacturing company. And when he kind of finished that journey up, he decided he wanted to do something on his own. He pulled me in, and my first reaction was space-based solar. That sounds really cool. I'm not sure that's going to work, which set me off at about 2 years of learning everything I could as aggressively as I could about the technologies behind it, what it really means with the amount of material you have to put into orbit and bring it together. And after about 2 years, we got our first funding check in. I finished looking at it and I said, "Hey, this is really something cool to go out and do and work on." And so I joined John, and I've been at it now for commercializing space-based solar for about 3 years.
Awesome. That's amazing, Ed. Thanks for sharing your story, and we'll get a little bit more into Virtus Solis and your mission a little bit further down in this podcast here. We really want to talk about the new space economy. I talked about it earlier. We really want to help everybody understand what that means and what are the key driving forces behind the new space economy. So Brian, Ed, take it away.
Very well. Do you want me to?
Yeah, sure, Brian. You go.
Oh, very good. Thanks, Ed, and thanks also to Reagan. A big shout out because we've been working together for a brief time, and all of it's been a delight. So thank you for that. Hi, folks. I'm Brian. I came out of UCLA a long, long time ago and joined the RAND Corporation, which is a think tank, one of the better ones. And I was entirely too young to be there, but I was given an assignment to catalog and understand all orbital assets all over the world from every country, and also to catalog and understand the entire launcher community. In those days, it was a tenth the size of what it is now. As an outcome of that, I was asked to join the Federal Communications Commission, which led me to being asked to give a presentation in Los Angeles I was asked by an aerospace engineer, a friend of mine, to come to LAX and talk to a group of people about potential for geostationary satellites as commercial machines, which there are plenty of them now, but at the time it was pretty rare. So I found myself in a room in an office building at the airport with a white pad instead of a laptop or a screen. And there were five people, five or six men, regrettably, in those days it was mostly men, who were wearing suits. And I was asked to speak for an hour. And 6 hours later, they said, "Look, come on, let's get out of here and go have dinner." And that night I was introduced to Alan Bean, Dick Gordon, and of course Pete Conrad, who were the mission people on Apollo 12. This is the flight right after the landing mission. 10 years later, Dick Gordon was best man at my wedding. And another 20 years later, he came to work for me. And we worked with Pete Conrad in developing some solid fuel boosters. So that's another story. In the interim, I've worked at Boeing, Sea Launch, FAA, FCC, NASA on and off for a time, Blue Origin, which I'm sure most of you know about, and most recently Axiom. For the last several years, I've had the pleasure and honor of being associated with Ed and John and all the people at Virtus Solis. I consider myself to be a pygmy intellectually with these people, but I'm a pretty good organizer, so that's what I do. And Ed, take it away.
All right, so Reagan, you asked the question of what's driving the new space economy. First off, I think everybody's seen the charts that show the drop in launch cost. It's gone from ridiculously expensive to just merely really expensive in terms of launch cost. But fortunately, we're on a path to have that cost keep coming down. SpaceX is leading the charge, but there's a ton of other companies that are coming in that are going after either niche or direct head-to-head competition with SpaceX. And all of that should keep pushing the price down. But there's a lot of things I think that are hidden behind the scenes that may not be obvious that are some of the trends that are actually making this possible. First off, one of the reasons that SpaceX is able to do things so much cheaper than others have in the past, and of course drive the price down, is because we've gone from a model of basically building a rocket and throwing it away every time we put something into orbit. So SpaceX has shown that they can recover the boosters. They're in the process of showing they can recover boosters plus the Starship right now, and the reusability changes it from being something where you have to spend tens, hundreds of millions of dollars for your launch vehicle to just basically paying for fuel and getting your vehicle to last long enough. The next thing that's not really obvious is continuous operations. If you look at the time that's going on between launches now, we are getting to the point that it's almost continuous repeated operations. Nowhere close to what airports are doing, but the flights themselves now are happening, literally within hours of each other, if not simultaneously within minutes of each other. And that's a big, big change from how operations used to look. And then finally, especially with SpaceX, they're pioneering this as a high volume approach to manufacturing. The lessons that I think Musk and his organization learned at Tesla in the automotive industry are being carried into producing engines, producing rockets now. And even as its latest Starship just went off, there's 5 more Starships at different stages of construction that are being queued up for the development programs. Now, through the entire industry, there's actually 4 more things which are hidden from sight. One is manufacturing now is a lot cheaper than it used to be. If you want to build a prototype, you can use additive manufacturing, contract companies are easier to find, and a CNC and some of the more mature technologies are all out there to drop the cost of building a one-off or even low volumes. Computation means you don't need to put men in space to make things happen. The advances in robotics mean I don't have to have a man in space to turn a bolt, to connect a piece together, etc. So we've got computation to be able to do the things that need to be done at the very edge of where you're working. We've got the robotics, which are replacing manned operations. And then finally, these things all let you drop the capital of making anything happen in space and decrease the time it happens. And this is where you're seeing this explosion of startups today that are putting nanosats up, that are pioneering entirely new business models of what needs to happen in space, and even disaggregating what used to be big monolithic programs into services that will deal with an ecosystem.
Yeah. And that's all amazing. Thank you, Ed. So I guess for the audience here, what opportunities are really available, and how can somebody get involved?
Okay, well, I'll go ahead and I'll jump in, Brian, and then you can follow up on it. I think one of the things that's happening is if you look at like the cosmic effort that's going on in the US right now, which is a consortium for on-space manufacturing and ISAM, there's a pointed concept of disaggregating all the things that used to have to go into making a mission work. So you think about a mission, I got to launch something. I usually have to do some operations. I may separate out a satellite out. The satellite has to maintain itself, maybe deployment, missions and operations for years, communications. It used to be all of that had to be crammed into just getting a satellite in the air. And today, you can literally, I believe right now, SpaceX, you can go and you can use your credit card and secure launch with a credit card and say, I want to launch this package in this kind of environment. So you can get launch as a service. You can take a look at communications being provided by a wealth of different suppliers for your communication subsystems, the electronic subsystems. All these pieces are maturing as things that can be brought together as integration, which is in the realm of what can be done by a small startup if they can identify a market need and they can figure out how to get the traction they need to start moving. And this is massive. I mean, you don't have to be a Northrop or a Boeing to put a satellite in orbit. College students are doing it out of labs right now. So that's really, really cool. That's a massive change. But this disaggregation now and the continuous operations means there's a chance to do all sorts of things in space. There's startups that are looking at how to provide power as a service, propellant as a service, communications as a service, all the thing, even persistent platforms as a service. I was at a conference last week and they were talking about being able to not even have to build a satellite, just build a module that goes into a larger sat that provides all these features you need. So it's find a market and figure out how to bridge that market and use space to make it happen.
Thanks, Ed. Brian? You're muted. Brian, you're muted.
Some people
Hi there.
say,
I just wanted to, Regan, can I please point out that people cannot see Brian and Ed when they're speaking because you have your video pinned for everyone.
Oh, really? Geez.
So we'll just unpin yourself, please. Thank you.
Okay, perfect.
And Brian, I'm not sure if you should be good to go now, Brian.
all right, very good. How's that?
Perfect. There we go.
Well, to follow on to what Ed had to say, and on this keynote of the new space economy, I tend to use analogies, and I'm going to keep this very brief. We talked earlier about dropping costs by increasing the efficiency of manufacturing and so forth. The new generations of rockets are more akin to semis, or even taxi cabs or Ford pickup trucks. They're produced cheaply or comparatively cheaply. GMC pickup trucks. So the principal way that these systems are developed is when you have to move commodities around. 150 years ago, you didn't have any choices about moving your wheat. You went to market in a wagon, and if you were lucky, there'd be a railhead somewhere nearby. And that infrastructure has obviously grown up with civilization and with society. What's lacking in space is the whole system of infrastructure, the highways, the regulatory issues and compliance issues of managing more and more space vehicles going up and in orbit. And in all respects, what we're looking at is developing a new supply chain. We've heard in recent years what happens when supply chains are interrupted in most recent history by COVID, that sort of thing. So the SpaceXs of this world, and hopefully coming right along behind them, the Blue Origins and Rocket Labs and even the Europeans, are in the business of trying to understand how to make their services cheaper and yet profitable. And it's complex.
Brian, I think a good comparison to make with this supply chain would be back in the Industrial Revolution, how they had to plan out the railroads and the canals to be able to develop and get products and services established.
And then we're going to need to see how much it costs to take a bushel of wheat to the marketplace using a Ferrari or a pickup truck. And that's the direction that Ed was describing. And again, these are analogies, but the opportunities for employment for establishing new businesses and enterprises are as really as unlimited as looking at all the stuff we produce on Earth and what value it may have in orbit. Obviously, we need meteorology satellites, we need our GPSs, we need our cell phones, and almost entirely now the web and the cloud are composed of orbital assets retransmitting. So we're going to need more and more of them. We're going to need cheaper and cheaper ways to get them up there. As Ed also pointed out, most of this stuff has a very short lifespan in space. So we'll be dealing with issues like what happens when they come down, how do we dispose of these materials, growing environmental issues. Again, each of these things, think of them as a business opportunity. Yeah. Go ahead.
Go ahead. Anyhow, I think one of the things that's great with the story you're telling is that, primarily what we've been doing in space so far has been moving information. If you look at where the money's at right now, the money's in communication sats, providing high bandwidth from one side of the globe to the other. And in fact, if you kind of play with it, a communication sat is actually worth more than its weight in gold by quite a bit in terms of the revenue it can generate today. So this has been the basis of the space economy to date. I mean, if you push out defense, you push out scientific missions, we make money by supporting the internet, supporting broadcast and everything else through satellites. The big changes that are coming, Starlink is building on top of that, but there's now people trying to do pharmaceuticals in orbit. There have been a couple of successful tests on that. You're looking, actually, I just saw a startup recently that's actually doing point delivery using space, which I imagine if it absolutely positively has to be there in 2 hours, that's the way to make it happen. But they're literally going to drop a capsule on your head with a parachute, from what I can tell. And it's, I'm assuming there are places where the point to point may be worth it, getting something down on the ground that quickly. But, we're going to move from information, moving photons to deliver value, to moving well-structured atoms to deliver value. And the scientific spending, I think, is going to continue to increase. The defense spending is going to continue to increase. But then following those two, you're going to see industry coming along and moving from photons to atoms.
And one interesting point you said, so zero-G testing. So let's talk about that for a second with pharmaceuticals. So one of Avro's missions is to be able to deliver payloads to the von Karman line, which would allow for zero-G testing on drug synthesis and even seeing how certain drugs affect cells because the zero-G environment changes how they react, and there's a time difference as well. So I just wanted to bring that up, and that's a really interesting fun fact.
Yeah, like zero-G biotech lets you build things you simply can't build on the ground. I mean, you can either make really good crystals that are defect-free in zero-G. You can also build like biological structures that can't be built in 1G. Things that Mother Nature may take care of very naturally.
Large organic molecules.
Yep.
For one thing. So let me add to Ed and Regan's comments. From my point of view as an insider in Virtus Solis, quite apart from the extraordinary technology development and proof of concept now and demonstration, there's the whole other side of the world, which is it worth doing something, especially something that costs this much, which is kind of like saying, is it worth building power utilities or is it worth building highways? Of course it is. But in general, investment, especially private investment, does not think in terms of decades. In fact, regrettably, for the most part, many private investing organizations want to see a return very rapidly. Our economic models, Virtus Solis economic models, which John and Ed and a few others of us have worked on developing, stand the test of math. They stand the test of reality. They stand the test of logic. And one of the ongoing objections in general to space operations is it costs so much to get up there. There's such a high risk, and both of those things are being reduced. Those very real factors are being reduced. So it's the economics. It's the economics of space that matter.
Yeah, and being able to predict those economics.
Yeah, if you don't mind me just doing a diversion here for 1 second, it's like I can give you my own background. I worked on electrification of vehicles. So I'll show my gray hairs here. It's like my first vehicle program started in 1990 working on the EV1. And I can tell you, as somebody that was in the middle of that, we were starting with lead acid batteries. We moved to the next technology, which was nickel metal hydride, which at the time was incredible for the advances it made. And lithium was still off in the distance. And I remember seeing those curves when I first started working, and it showed this exponential decrease in cost. And when you started looking at this, you go, I'm building something today and it costs this much money. There's no freaking way this price is going to collapse by that much in a time that's meaningful for anything I'm doing. And I still look at what's happening today with the EVs on the road. The ranges are now getting, the amount of energy that's in those batteries, the size and the mass of the batteries. And I can still tell you that I look at it and my youthful self says that just didn't work. That can't be the case today. And I'm slowly getting used to just seeing the prices have dropped and accepting it. I got to believe a similar thing happens if you've been around aerospace, and maybe you can speak to this, Brian, your entire life. If you cut your teeth when the shuttle was flying at tens of thousands of dollars per kilogram to put something in orbit, high prestige missions where if anything goes wrong, the entire program is going to be shut down for weeks or years, like happened with the shuttle program. The way the industry is moving today is a wildly different animal. I mean, basically, the first Starship that went up blew up. A big deal. A couple months later, the next one was flying up, and it wasn't like that was a critical event. That was just simply another bump on the road. And so the nature of how the industry evolves, how these things do, the tolerance for failure, the rate and pace that things happen, and now finally the cost, are all wildly different. And if you started at the top of the cost curve, it's very hard to, really fundamentally believe this is where we are, and there's going to be a decade, 2 decades of rapid price drops. And it's just something that I can tell you from, where I'm at, that's if you grew up with it, it's hard to see those changes. And I've got fresh eyes to it. So it's like, oh, of course, I can look at all the data and go, yeah, this is dropping. It's going to continue to drop. But if I had been in it my entire career, I think it would have a very different response.
Let's add to that with respect to the economic model. Yes, we hear pronouncements about it's okay to lose a few ships, and that God knows they lost quite a few in development at SpaceX and other organizations, Blue as well, and even Ariane in the old days, and Atlas and Vulcan. The Saturn rocket, which is my personal lifetime favorite, never failed. From the first one until I think the 13th or 14th, it never failed. This wasn't because failure was impossible. It was because they were built one by one. They were built by the engineers that designed them. There was very little to interfere between the designers, the engineers, and the scientists in doing the work, and were inspected like crazy. The idea of testing to failure, absolutely the case for aircraft. It has to be done. But for rockets in those days, it wasn't, which resulted in very costly, very precious, just a few of each one of these products. Again, moving to the new model, which is actually based on NASA's help and the entire engineering community. The new model is really nothing more than the old economic models, the original automotive manufacturing model. So again, just thinking about this in terms of our time, do we want to cover some of the employment opportunities?
Yeah, career opportunities for sure. Yeah.
So Ed, why don't you start with that, because we have slightly differing ideas about opportunities.
Okay. Well, I mean, what you can do is you start stacking up, what does the space economy involve? So first off, it involves a lot of processing of data. And, being able to take a look at those hordes of data coming in and doing something useful with it lines up very, very well with traditional computer science. I hate to say AI, but, the AI processing of that data coming in is, an immediate need. And we're generating more and more of it. Why are we generating more and more of that? Because the communication engineers are making it possible to use, not only the existing channels more effectively, but they're bringing in laser communication to the point that we're looking at terabytes a day coming down from potentially just like one captive network. And you want to do something valuable with it, which means sifting through it, trying to find gold among the piles of hay that are coming down. All right. Then we've got the mechanical, aerospace engineering, all the traditional things to build the hardware that goes up there. Those are, going to be very clear. I think that's easy to see. But then we got other hidden things, thermal. You start building bigger stuff in space. It's really tough to make anything get rid of heat. We think of it as cold. The movie shows somebody freezing. The reality is turn a microprocessor on in the vacuum of space and it's going to cook itself. So you've got to be able to move that heat, get it out of the system without it getting in the way. You need to collect the energy to do something useful. Solar panels and all that. So everything we're learning on the ground today, it's a little bit of art to convert it to being usable in the space environment. So basic physics, basic material science, all of those skills there can come into play to make better materials, better performing sensors, power conversion, et cetera, that's for use in space. Even just the things that I know from automotive, it's like when I look at a satellite and how it wears down, it's no different than how a car wears down. It's just different chemical processes. Monoatomic oxygen attacks it and effectively corrodes it. You've got small little bits of dust, debris that will tear at it, no different than rocks pitting your car on the road. And there's a whole host of chemical processes that happen in zero G you're never going to see on the ground. So all of these things are just the same basic engineering sciences that support what we build on the ground today, just with a different application in orbit. And then system integration, requirements management, all of those things which are about how to build a great product. Those are yet, another area that, people can be brought in to work with it. And then when you look at what's going to be done, zero G chemistry, entirely new area that enables zero G biotechnology, zero G potentially bioprinting, additive manufacturing in orbit, and the challenges that go with that. And probably the biggest one is going to be garbage management. For lack of a better word, we always talk about it as debris, but right now we have about 13,000 tons of stuff in orbit. It's just going up more and more by each year. And that's a wealth of material that's available to jumpstart a host of other services and capabilities in orbit. And that needs to be cleaned out. If we let it stay up there, it becomes debris that gets in the way. So how to actually turn it from an open loop system we have today where we throw stuff up, we throw it away at the end of life, to being more of a closed ecology where we put stuff up and now it's valuable and we've got the mechanisms to recycle it, reuse it, repurpose it, etc. So that's just a handful of places that this can be attacked. Brian?
And the more we're able to do that, the more accessible these it will be for startups, say in Canada, to get involved in zero G testing. I know that there's a startup that sent some stuff over down south to get their testing up there. But just imagine Canadians having access to a more local and cost efficient alternative.
Well, let me proceed on the employment opportunities. Virtually every second word that Ed just said was a discipline. Thermal management is becoming tremendously important as systems get bigger and bigger. I guess most people have this view of space, the ice crystals form and people freeze to death. For the most part, it's the opposite. Electronics in particular are highly sensitive, and those great big bulky spacesuits that you see are mainly cooling systems rather than heating systems. So going through that, everything from managing debris, which two of my students got internships to NASA and to ESA on little schemes to manage debris, through all the biosciences, space medicine. NASA has something like 300 doctors that work medical issues and scientists who work all kinds of biological issues. We've learned a lot about how human bodies deteriorate under zero G, and those are important issues for space medicine to address. One thing that I've always remarked on with my students, my undergrad and grad students, is that most of them aspire to be software engineers, and that's a lovely and noble profession. But the reality is that India alone is producing more very, very capable, albeit sometimes narrow, very capable software engineers than the rest of the world combined. So what I tell my students is have a major and have a minor and have them be complementary. If you believe that your real métier, your real strength is software engineering, go for it. That's your major, and have a mechanical or an electrical or a thermal or a structural minor in there. You can always learn more software. You can always learn more about any of these disciplines, but you don't want to make yourself only employable in one area. And I've said it a lot of times. Our joke at Virtus Solis is that the software engineers write the sheet music and the hardware engineers make the pianos. So none of this stuff works without anything else. As far as opportunities, private opportunities and public sector opportunities, if I were starting out again, I would be looking almost exclusively at private organizations. You might even try, if you have the means to do it, getting involved with a startup pursuant to joining one of the bigger companies. But above all, I would head for the private sector. In my day, originally, it was NASA or else, if you wanted to be involved in the actual construction of rockets. But now that's spread out all over industry. And Regan in particular, I know that we've sort of been keeping track of possible employment opportunities, cross-border kinds of work. In fact, Virtus Solis is also working with Avro through Regan's great connections. So also, I urge, I'm happy to put my my email address up here. Or if any folks have any questions about employment, I'm glad to discuss that. That would be a pleasure.
Thanks, Brian. And we'll leave that to questions at the end. Hopefully there's some. So as this is an Entrepreneur Week event, we really want to take the entrepreneurial approach to how we talk about our businesses and the problems that we're solving. So I'd really like to highlight some really important things when considering a product or service, and that is having a strong mission, a strong unique value proposition, having a strong go-to-market strategy, and a minimal viable product. And so probably hear these terms spoken about all over the place. So we just want to connect it to what Ed and Brian are doing at Virtus Solis, and then getting into the challenges that you're going to have to overcome.
Okay. Well, I mean, first off, it's like, we'll start with Virtus. We're really an energy company. Our role is we're commercializing a special kind of solar power. And this is solar power that can do something we can't do on the ground, which is provide power 24/7 and provide it in any weather. So that's the unique selling point that we have, is high capacity factor. That's a term the industry uses to say it's always available, dispatchable, renewable, clean energy. Our fit is that we look on the ground just like a solar farm, except we're smaller and we deliver power all the time. And the unique selling points we have is, in addition to, because we can do this power constantly, then we don't need to have batteries in the network to make up for the fact that we're not generating power at a certain point. We don't need intercontinental or continental scale network build out to try to move from sunlight at one point and wind at another point to try to mix them together. We can simply go within a reasonable distance from a customer, bring the power in. And our unique point we're going at this is looking for people that need this as behind the meter initially, which is delivering power to folks that are looking to have control of their destiny with power, with clean power and in large amounts to do whatever they need to do. So that is the overall bit we are chasing after as a business. We're an energy company. We happen to use space to make it happen, and we get a very unique way of getting clean power on the ground that's effectively unlimited. And one of the things I'll kind of mention, that a lot of people think of solar, they think of it as a very weak source of energy. And on the ground, yeah, it is. If I try to collect energy here in Michigan, I spend a lot of the time with hardware that's doing absolutely nothing. When we look at moving solar collection into orbit, even with all the losses that take to get it on the ground, a space-based solar plant actually has about the same energy density as mined uranium. And I want that to sink into people's heads for a minute. When I go out there and you find a great patch of uranium, you dig it out of the ground, and then you push it through the pipeline to eventually put that into a nuclear reactor, we basically start with similar but a lot more common materials. Sand that gets turned into the semiconductors, a handful of aluminum, copper, and other metals, and we assemble that on a gram per gram basis. We have as much energy over the lifetime of what's assembled as you're going to get out of digging uranium out of the ground. So that's an incredible value proposition there that's not fully understood, and it turns solar from being kind of like this weak diffusive power, and in those terms now it becomes something which is on the same scale as nuclear, and we deliver power with the same potential that nuclear has. So I've finished my sales pitch.
Yeah, and on top of that, like, so nuclear versus solar, and I know Brian could probably talk well to this, he has before. So we have, when we're considering sustainability, we have to, and the value we get from these energy sources, we also have to consider the effects that it would have on the planet. So Brian, maybe you can touch on that. You're muted. You're muted, Brian.
I think some people appreciate it when I'm muted. I going on about energy density. If you will, imagine a gallon of gas, which weighs about 6 pounds, and a battery, a lithium battery that weighs 6 pounds, and try to figure out, this is a physics issue, try to figure out how many miles you'd go on a gallon of gas, depending on what kind of an engine, and how many miles you'd go on an electric bike or electric scooter with a 6 pound battery. That's a way of thinking about energy density per unit. How much power can you realize out of that? One of the many challenges of building more nuclear power plants is that they have to be located in areas where you have trimodal, obviously. You need highways, you need rail, all of that stuff, and you need cooling. And we have learned to our concern that the most vulnerable parts of any nuclear power plant, and for that matter, fossil, are the cooling systems. This is what we learned in Fukushima. That was the biggest problem there. So solar power density, and again, you can imagine that another way of looking at photovoltaics and photons is that you concentrate them in a magnifying glass, and you can burn stuff with just 3 or 4 square inches of glass to focus and concentrate it. Our systems don't focus or concentrate. We don't have pinpoint beams. We have flat beams, planar beams that cover approximately the area of our ground stations where we receive it. We use microwave energy. We convert photons into microwave, RF, which is one of Ed's specialties. And the power density on the ground is higher than standard photovoltaic, and at the same time does not require building a lot of very expensive, vulnerable infrastructure. Again, there are aspects of this that are very complex to understand. We use a particular model called LCOE. It's, again, complicated. It's levelized cost of electricity, levelized cost versus coal versus wind versus solar versus XYZ. And in each instance, nuclear comes out pretty well if you don't consider the requirements for decommissioning a plant. It's
Life cycle.
The life cycle costs, cradle to grave, we used to call it. So if you look at nuclear power in terms of a business activity, generating power, giving it to utilities, it's fine until you have problems, at which point the problems can become spectacularly expensive to solve and potentially very dangerous. Fossil, we got to get rid of. There's just no way around it, no question about it. If only to reduce the global heating, but we're going to need oil, and we're not going to need it for transportation. So again, you do the numbers, you do the calculations, and as Ed says, we're in the energy business. It's wonderful. We're going to build spacecraft. That's my thing. But we're fundamentally in the business of providing 24/7 power around the planet. Again, this is not dependent on nighttime, daytime.
So let's talk about the economics of this. So how does the supply chain need to shape and look like, and the economics for this to be possible?
Well, a lot of the main pieces are coming along. So, I mean, we've got a very rich ecosystem coming up with the launch providers. So there's a lot of options on how to get the materials you need. We'll call it logistics, where they need to go. The in-space assembly. There's only just over a dozen robots in space today. But that ecosystem is very quickly growing along with a lot of different approaches to be able to do assembly in orbit. Within the next couple of years, you're going to see an absolute explosion of what's going on with in-space assembly, including pioneering new manufacturing processes and things like that will be proved out in orbit, that all are key parts of being able to make this happen and make it happen very cheaply. So then the last pieces for the economics is converting away from a craft sort of building things and converting away from every piece has to work perfectly every time. And with space-based solar, one of the things that we're very blessed with in terms of our design is that it's massively redundant just by its nature. Losing a solar cell is not a mission critical event. Losing a microprocessor will not be a mission critical event. Losing an antenna will not be a mission critical event, because there will be very, very large numbers of all of these things working in parallel that will step into the gap, and it will just gracefully degrade. So the basic economics are, we have an ecosystem which is maturing, which means the services and things that we need, we could buy today and make it work. but 2-3 years from now, we're going to be in a much better position. The ecosystem to do certain key aspects, some of the semiconductors, some of the other pieces, there's not a fully mature supply chain that can produce in the quantities we need, but that's something that can be resolved within 2 to 3 years by supplier development. And we're in the process of doing that right now. So all the indicators are that this can come together. This can be made to work, and a combination of the existing space economy and terrestrial economy suppliers are all poised to be able to make it happen initially and then grow it at scale very, very quickly.
And thanks for that, Ed. So Brian told me a fun fact a while back, but how are we going to get this stuff up there? How many rockets are you going to need? And what does the cost per kilogram need to be at? And I guess how much money do we need to get it up there too?
Let's talk about energy in general at first. So when we start talking about energy, the cost of building a solar farm today runs into the billions for a utility scale solar farm. The cost of building nuclear power plants, tens of billions of dollars, and these things are done on timescales which can be out into the decades. So with what we're looking at, actually, it's relatively small compared to a large solar field, or it's relatively on the order of a large solar field, and we produce a lot more power. It's a lot cheaper than a comparable nuclear plant. And the build times actually are limited by primarily what happens on the ground. We start looking at doing things on the ground, there's a whole host of regulations that have to be followed. Site evaluations, permitting, environmental impacts, and all that. These are things that we're in the middle of. The stuff that we have to go into space is actually much simpler in terms of regulatory compliance, in terms of the other things that need to be done to make sure that we can get up there and satisfy the rules and agreements that are there. So, you ask the price, we're going to be on the order of a very large solar farm. You ask the timing, we're a lot less than putting a nuclear power plant together. And the ecosystem with all the suppliers we need is coming right along. And we see all that being in place by the end of the decade, it being possible to start turning power on. And we're not the only ones that are saying this. There's actually several of, between ourselves and some of our competitors, we're all saying the same thing, that somewhere around 2030, turning on light bulbs on the ground using power from space is going to be a reality. And between national efforts and commercial efforts, that looks like there's a lot of ways to get there.
That sounds great.
There's a sort of an imaginary rivalry between various sources of energy. Again, there's a lot of uranium. It's also quite dangerous, toxic to mine and refine. There's obviously a hell of a lot of coal and oil and so forth. But among the many problems that, for instance, the nuclear community is facing is siting. We've learned some lessons from disasters around the world and a couple of pretty serious events here. And try to imagine, you're in the cities that you all live in, there's an announcement that the Department of Energy or your equivalent in Canada wants to put up a nuclear plant 5 miles away from where your kids go to school. It can take a decade or more just to get approval for the site, let alone the engineering. And during the process, the acceptance process is what it's called, there are many legal challenges, environmental challenges that you could face. So a major factor in why these developments are cost effective and relatively easy to get regulatory approval is we're not interfering with anybody's real estate. We're immune to physical attacks. We're immune to natural disasters. We don't have any dams breaking. We're not getting any nuclear releases or fossil fuel gases, so forth. Jurisdictional. There are a couple of mines up on the Canadian-Washington border. They've been leaking lead into Washington water sources for half a century. We're still trying to fight that battle. And when any time you design any plant terrestrially, you also have to build transmission. And I can tell you from personal experience working nuclear facilities, transmission can cost $1 billion per mile. So if you're running, let's say, 100 miles from a nuclear power plant to a city, you're looking at another $100 billion in terms of an actual build-out cost. We co-locate with existing utilities. We put our ground stations next door to the power plants, next door to the fossil plants, and we use their transmission systems, which means distribution is taken care of. Each one of these things take another zero off the costs. So while our numbers look big going in, over the life cycle, they're more than justifiable, certainly more so than terrestrial power plants.
So we're getting close to 2:30 here. We've got about 7 minutes left in this specific segment. So I guess just thanks so much for the great discussion and conversation. Really just want to go into just what's one piece of advice that you would give to anybody wanting to get into the space economy as an entrepreneur or as a career, just one piece of helpful advice you've learned on your journey. Ed.
One piece I've learned. I'd probably say a bias towards action. Although getting out and just simply doing something is useful. Make sure it's the right thing that you're doing. We're working on hardware, so hardware is a little bit unforgiving because it's not just a matter of recompiling it. It's actually a matter of potentially having to pay for tooling, paying for all these other things that come into making it work. So you want to make sure if you do something, you do it in the right direction. The other one is talk to customers. I mean, just spend time talking to the folks you're planning to help and make sure you're solving the problems they've got rather than taking your assumptions about what needs to be solved and working on that.
Okay, and the way I think about this is that NASA has a system called System Mission Analysis and Design. This is a long-winded way of saying you have to decide what you want to do. You have to decide what's valuable, what's worthwhile to NASA, what's worthwhile to aerospace, what's worthwhile to society. You have to decide what it is you want to do before deciding how you accomplish it. So the next step is to look around you, be analytical, look at what things are obviously growing, what issues in space. Obviously, cheaper manufacturing, biomed. There's a whole range of things in the sciences, administratively, in finance. Look at things where there's a growing need and then see how they couple to you. People say, do what you love for work. Very few of us get that opportunity. But as you see the things that your thoughts and your desires and your intelligence are leading you to, look for where those connect. And the aerospace community is vast. It's obviously worldwide, and it contains room for dozens and hundreds of disciplines. So find what you like to do and find out who out there are the customers for what you do, and plan your education around that or your business plan.
Thanks, Brian. Really appreciate that. And on my side, just like what Ed said, action creates data. And every step has taught me that I either win or I learn. And so wins will build momentum, which is extremely important when you're starting a business. Make sure you get that momentum. And when you do, just take advantage of it. And of course, setbacks uncover just the lessons that are needed to adapt and grow. So the path really just becomes revealed as you start walking it and learning. All right. So I guess that's we're ready for questions and all that stuff. I guess we could probably just go as long as the questions keep coming in. So if anybody has any questions, just type it into the comments and we will work to answer them. Or you could put your hand up, I guess. Everybody has access to say something too. So
we have a question. So it's from Will. This is the second time he's attended this event, and he's very aligned with your approach to engineering and technology. And it says that he's built an engine prototype that is showing promising results applicable for silent propulsion and satellite propulsion. So Brian, can he connect with you via email to ask for some mentorship on a way to develop the project?
The short answer is yes. And just a second here, and I want everybody to have this at their hand. Yes, Will, I would be delighted to do that.
Awesome.
So if you weren't aware, Brian just put his email in the chat.
Very good, Will.
Yeah, I mean, while we're waiting to see if any other questions come in, I'd make one comment from something that was said earlier, especially for folks that have got a software bent, and that's kind of where they're looking to head. I mean, the reality is I've got interns, and I think every one of the interns that we've had in has ended up writing software that builds on the other skills they've got, whether it's automation of CAE, programming an embedded controller. I've even got one student that's studying physics that has been taking electromagnetic equations, and he's been updating some of the simulators we've got, and it's a definite support skill for whatever you're going to work on. But having some other deep area that you know well just takes that the computing skills you've got and makes them that much more leverageable. They give you the ability to take what you know mathematically and turn it into something that others can replicate and that others can scale.
Thanks, Ed.
Okay, we have another question in the chat. If you could name an element which is key for space industry, what would it be?
Venture capital. It's still outside of what you can self-fund to put something up into orbit. So, I mean, the best business is when you can self-fund and you can take from scratch and grow. You're going to have the most control over it. You're going to have the most control over your destiny. The reality is it's still really expensive. I mean, you're looking at, $1,000 plus per kilogram to get something into orbit. And, a kilogram's not much of anything to put up there. So these are still programs that if you're getting, you're trying to self-finance can be incredibly expensive. So you're probably committing yourself to something where you either have to have some angels to get you started, whether it's a rich uncle or a neighbor that loves your ideas, or you're looking at going into the whole VC route. And, if that's what you're going to do your best to learn how those things work. Do your best to find out, how the different stages go in there, and then, make a run at it. But I think that's the technologies have been laid down. And so now it's really a matter of trying to figure out how to seize on those things and scale quickly into it.
There's been questions about education. So I'm going to make it easier because we don't have unlimited time. Just use that email. And if I don't have real good answers for you, I will pass you on to someone who does.
And we got Max have his hand.
Oh yeah, there we go. Perfect.
Hey Max, you have your hand up. You can go.
So first of all, thank you for the talk. Now I'm from Europe, and I wanted to ask, given your view from across the pond, and given the American and Canadian space economies and space industries, what are your opinions on the European space market, specifically given how sometimes we say that Europe is falling behind, especially when compared to companies like SpaceX or Blue Origin, whereas we mostly rely on the big government companies like Arianespace, who are, to put it mildly, not exactly picking up the ball. So yeah, I'd be very interested to hear what you guys think about that.
I'm sorry, who's speaking?
Me, Maximilian Koch.
Oh, hi, Maximilian. Yes, sorry. We are, as a company, Virtus, we're developing partnerships in Europe now, even as we speak. Everything has been turned upside down and on its head. Some years ago, about 8 years ago, when he who should not be named was elected, Macron in particular talked about what wonderful opportunities lay ahead, obviously through cooperation in NATO and co-jointly developing space technology and so forth. You're right about Ariane. It's sad, but they're brilliant rockets. I know some of the people who were designers, but they were designed at a time where relanding and reusing were deemed unfeasible. That was a mistake that ESA made. Fortunately, we had some private people here who were willing to override NASA's objections to that. European space is going to grow because it has to. I think that recently Macron and other European leaders, those who haven't been recently deposed, have been talking about an independent, strategically equipped Europe, and that includes developing new categories of rocketry and satellites. Europe has not deployed any major defense satellite systems for many, many years, and that's going to have to be organically developed within the ESA and within the EU. The national space agencies, DLR, for example, in Germany, are also embarking on R&D programs. And my understanding is that they're going to their governments and asking for more money. I think we're all of us seeing what's going to be happening with China on the horizon. This is not a parochial view. I'm European. I have European citizenship as well. I think that it is incumbent, absolutely an imperative for all European leadership to re-look at how you're committing resources. This isn't about NATO or anything like that. It's about the immense capacity that European nations have to work collaboratively to building good systems and getting the political will to do it. And again, communicate with me. I'm always happy to have conversations.
Thanks for that, Brian.
With pleasure. Another message. Oh, there we go. Yeah, yeah, with pleasure. So, I guess if.
Hi, everyone. We have another question.
Yes.
It says they've already touched on this topic, or sorry, if you've already touched on this topic. But do you work with military contractors, or do you try and distance yourself from the military and military related projects?
Okay.
Very perceptive question. Ed, you go ahead.
Okay. I was going to say, there's the reason you would go after military contracts is because that's going to be your ultimate customer, or that's a source of non-dilutive funding. We've been focused very heavily on going after non-dilutive funding from like the Department of Energy with ARPA-E, NASA with some of the innovation grants that they have, and various competitions that are out there. At the end of the day, the service we're looking to provide is energy. We're agnostic to who we provide it to, and we'll work with anybody that is needing the type of energy that we can provide.
I would say the same thing just with our business model. Obviously not providing energy, but propulsion systems.
I'll finish that off by saying you're Human, that you're very wise to point out how some organizations try to steer away. In the U.S., one problem that we have is that in many ways our aerospace and space environments are non-competitive. We have organizations that fund new defense research. One of them that I've done a lot of business with, and Ed and others in our company have worked with, is DARPA, the Defense Advanced Research Projects Agency. The problem is that they do give you money, but once you've used up that money, typically they'll turn over, if they deem it potentially useful technology, they'll turn it over to one of the big guys, and you lose control of your IP and all of your patents and the rest of it. So when you're going to eat with the devil, use a long spoon, as they say. So you have to be cautious. You have to be cautious about how and what you want, what you want and how you ask for it with the defense departments. Having said that, they've also funded a lot of very useful technology.
Thanks, Brian. Okay, so I think it's time to wrap it up. Really appreciate everybody joining today. Really a big thanks again to Ashley and Hannah and Ed and Brian. Thank you for this. It's a beautiful thing. I'm really excited we got to do it, and really excited to do more of this stuff. So stay tuned for that. But otherwise, we're going to sign off and onwards and upwards into space thereafter.
Hey, thanks for having us, Reagan.
All praises to you and Ashley and to Hannah and to Gate. And thank you.
Thank you. Bye, everyone.